Hi class, in this lecture here we're going to talk about how you find the derivatives of inverse functions. Okay, so in this section here's what we are going to do. We're going to talk about how you find the derivative of an inverse function. I'm also going to do a quick review of what exactly an inverse function is and some of the properties of inverse functions. And then we're going to talk about how you differentiate an inverse trigonometric function. So there's going to be, there's 6 inverse trigonometric functions. So there's going to be 6 formulas that I'm going to show you for this section. Okay. So first off, just recall inverse functions, okay? So if you have this graph, okay, you have this graph y is equal to f of x. This is your function, okay? The graph of f inverse of x, okay, so this is the inverse function right here. This -1 here tells us is the inverse function. Is the reflection of the graph of the function f along the line y is equal to x. So if you were to take this graph here and reflect it around that line y is equal to x, this is what the graph of the inverse function would look like. All right, and also just let me give you some properties that we're going to need in this lecture here, okay, about inverse functions. So just recall the following. The first one is a great property about these functions. If you take f of f inverse of x, that's going to be equal to x. And then 2, similarly, if you take f inverse of f of x, that's also equal to x. And then finally, this was another one that we'll use pretty early on here, is if you have f of a is equal to b, well then f inverse of b is equal to a. All right, so these are all things we've seen in pre-calculus. Excuse me, when we talked about inverse functions. So just a quick review of those. All right, so here's the formula we're going to work with initially. And it goes like this. The derivative of an inverse function. Okay, so let's let f be a function that is differentiable on an open interval I. If f has an inverse function g, okay, so just to note here, okay, this g is the inverse function. So instead of calling it f inverse, we're saying g of x is equal to f inverse of x, okay? Then this function g, the inverse function, is differentiable for any x for which f prime evaluated of g of x is not equal to 0. And moreover, okay, this right here, g prime of x, what this is, just so we're clear, this is the derivative of the inverse function. Okay, the derivative of the inverse function is equal to 1 divided by the derivative of the initial function, the original function, f, evaluated at g of x. Okay? And it's like, that's a pretty weird formula, and does it work? I don't know. Let me prove to you that this formula works here. Okay? And with a very, very simple example here. Okay, so this is our formula. The derivative of the inverse function, which we'll call g prime of x, is equal to 1 over f prime of x, or f prime, excuse me, evaluated at g of x. All right. So let me start by defining the function f. Let's let f of x equal x squared. Okay. Well, we know that the inverse function, okay, f prime of x, which we'll call g of x, we know this is actually equal to the square root of x. And this is for x greater than or equal to 0, obviously. Okay? Well, look, let me show you what the derivative of the inverse function is. So we know the inverse function here. So g prime of x, okay, if you were to take the derivative of this, you would just get 1/2 x to the minus 1/2 power, which is 1 over 2 square roots of x. Okay, that's what this just g prime is equal to. Now let's use this other alternative formula to show that we're going to get this. Well, we see that f prime of x is equal to 2x. So using the formula now, g prime of x is equal to 1 over f prime of g of x. Well, what is g of x here? Our g of x is the square root of x. So this would be 1 over, well, what is f prime? f prime is 2x, but now I'm plugging in, instead of x, I'm plugging in the square root. Look, same thing. Okay, the formula works. All right. So let me just do one quick example about this, just so you can see another way that this formula is used, and something that might come up on your homework. All right. All right, so let's use this function. Let's use f of x is equal to 5 minus 2x cubed, and the given real number a is equal to 7, to find f inverse, the derivative of the f inverse of function evaluated at a. So our goal, okay, this is what we want to find, okay? We want to find f inverse, its derivative, evaluated at 7. Okay, that's what we want to find. So it's like, well, how do we do that, right? All right, so we're going to use this formula, okay? So we're going to use the formula g prime of x. And remember what g is. G is the inverse, okay? All right, g is the inverse of this function. And I'm not even telling you what it is, okay? This is 1 over f prime evaluated at g of x. Okay? Well, in this case, what we're going to do is we're going to end up plugging in 7. But we need to do a few things here, okay? Notice what I'm going to be plugging in. I'm going to be plugging into the inverse function 7, okay? So really what's going on here is we're finding g prime of 7 is equal to 1 over the derivative of this function, which we'll get to in a second, evaluated at the inverse function evaluated at 7. Okay. Well, what does g of 7 equal? All right. So you got to ask yourself, what value of x would have the original function, okay? Because looking back at our rules here, all right, the original function, notice how when f of a is equal to b, well then f inverse of b is equal to a, would have f of x is equal to 7. Well, look, if you were to just solve this, you know, you'd subtract the 5 over, you know, and you can obviously see here that x would have to be -1, right? That's the only way that would work. So what we're saying here is look, when f of x is equal to 7, okay, so note, this is what's going on. F of -1 is equal to 7, so that means g of 7 is equal to -1. So this right here, g of 7 is just -1. So this is 1 over f prime of -1. Well, now what is f prime, right? So f prime here, so f prime of x ends up just being the derivative of this, which is just minus 6x cubed. So this is 1 over minus 6 and then times -1 squared. I think I misspoke there. It's 6. F prime of x here is -6x squared. I think I might have said x cubed, but regardless. -1 squared is 1, and then you have 1 over -6, or just -1/6. So you just had to use your rules of inverse functions to be able to solve this. And so what happens here is the textbook uses this formula here, going back, this formula here, to help you derive the derivatives of trigonometric inverse functions. So I'm going to tell you this, the proof of of some of these formulas are in text. So I'm not gonna solve them here for you here, but what I'm just going to show you is how you apply these formulas. So let's let u be a differentiable function of x. And then so we have the following derivatives of the inverse trigonometric functions, right? Like arc sine is a sine inverse, right? So the derivative of arc sine of u, and now so u, okay, is a differentiable function of x. Okay, so it's really, you're also seeing the chain rule applied in here. So the derivative with respect to x of arc sine of u is u prime over the square root of 1 minus u squared. The derivative with respect to x of arc tangent of u is u prime over 1 plus u squared. The derivative with respect to x of arc secant of u is u prime over the absolute value of u times the square root of u squared minus 1. Derivative with respect to x of arc's cosine of u, that's just negative u prime over the square root of 1 minus u squared. The derivative with respect to x of arc cotangent of u, that's equal to negative u prime over 1 plus u squared. And the derivative with respect to x of arc cosecant of u is equal to negative u prime over the absolute value of u times the square root of u squared minus 1. All right. I just want to go through a couple quick examples of this, just so you can see how to apply these formulas here. All right, so in each of these, find the derivatives of the following. All right, so here'll be the first one. Let's let f of x is equal to arc sine of 2x minus 1. Okay, so you're just going to use this formula here. My u is 2x minus 1. So f prime of x is equal to u prime. Well, that's just 2, right? Because the derivative of this is 2. So this is 2 over the square root of 1 minus u squared. So this is the square root of 1 minus u squared. And my u here is 2x minus 1. All right, so what you have to now do, unfortunately, is clean this up. All right, so this is 2 over the square root of 1 minus, and then when you square this out, you end up getting 4x squared minus 4x plus 1. So you have to keep going, right? So this ends up being 2 over the square root 1, and then when you distribute this negative 1, this becomes 1 minus 1, so that's gone. So this becomes minus 4x squared plus 4x. So I'm going to flip those around. So this becomes 4x minus 4x squared. And then do you notice how they both have a 4 in it? So you could factor the 4 out, and then the square root of 4 becomes 2. So this is 2 over the square root, the 2 came out here, sorry, x minus x squared. And then the 2's cancel, and you're left with just 1 over the square root. And you could even factor out an x here, x times 1 minus x. So you have to go through and you have to simplify these where you can. All right, let's try this one. Let's look at f of x is equal to arc tangent of e to the 3x. Okay, so all you're going to do is you're going to say, okay, I want to find the derivative of arc tan. So look, I'm going to use this formula. Derivative with respect to x of arc tan of u is u prime. So what is the derivative of e to the 3x? Well, that's 3 e to the 3x. You have to use the chain rule there. Over 1 plus u squared. So this is 1 plus, and then this here, e to the 3x squared. Well, just cleaning this up a little bit here. This is 3 e to the 3x all over 1 plus e, 3x times 2 gets me 6x right there. So again, just straight up applying the formula here. All right, let's just do a couple more here. Okay, so again, so in these examples here, let's find the derivatives of the following. You know, f prime of x for the following. Okay, I really like this one here, actually. Let's look at f of x is equal to sine of arc cosine of x. Okay, so this is a fun one here. So you're going to have to use the chain rule. All right, so f prime of x. So you take the derivative of the outside, which is sine. So that becomes cosine times arc cosine of x, I'll talk about what that cleans up to in a second, times the derivative of here, arc cosine of x. So you just have to go and look, derivative of arc cosine of x, in this case it's u, but so it's just minus u prime divided by the square root of 1 minus u squared. All right. Well, the derivative of x is 1, so just minus 1 all over. And in this case, it's the square root. And then going back, 1 minus u squared. Well, my u here is just x, so it's 1 minus x squared. Now, cosine of arc cosine of x, well, that's f evaluated at its inverse of x. So this here, cosine arc cosine, is just x. And then you can distribute the x through, and you're just left with negative x over the square root of 1 minus x squared. Let's do another one. Let's look at this one. F of x is equal to x squared times arc cotangent of x. So here you're just going to need to use the product rule, right? Okay, so you're going to take the derivative of x squared, so f prime of x is equal to 2x times arc cotangent of x. And then you're going to add to it x squared, and then you're just going to go look, well, what is the derivative of arc cotangent of x? So you're going to go here, arc cotangent of x, well, if this is just x, right, instead of u, the derivative of it is 1. So it ends up just being minus 1 divided by 1 plus x squared here. And then you could clean this up even if you want. So this just is 2x arc cotangent of x minus x squared over 1 plus x squared. All right, and let's just end on this one. Let me do one that involves one of those absolute value signs. So f of x is equal to arc cosecant of x cubed. Okay, so f prime of x here, that's equal to. So you're going to go back. What is the derivative for arc cosecant? So it's minus u prime. So this ends up being minus the derivative of x cubed, which is minus 3x squared, divided by the absolute value of u, which is the absolute value of x cubed, times the square root of u squared minus 1. Well, that's x cubed squared minus 1. So this just ends up being minus 3x squared times the absolute value of x cubed times the square root cubed squared of x to the 6th minus 1. And that's just how we just straight up apply the formulas for finding these derivatives. And you'll be all set now to find the derivatives of inverse trigonometric functions.